Okay, so welcome back. Now we're on to part 2 of thermal energy, thermal physics. Now heat is referred to as thermal energy and it is measured in joules. Heat is transferred from a hotter body to a colder one because of the average kinetic energy or speed of the molecules in a hot body, which falls as a result of the collisions with the molecules of the cold body. When the average kinetic energy of molecules is the same in each body, they are at the same temperature, which is referred to as thermal equilibrium. A thermometer is a device used to measure the temperature of an object or a substance. Thermometers rely on properties that vary with temperature. There are many types of thermometers. You have liquid and glass, thermocouples, gas, and infrared thermometers. Any property of matter, if it varies continuously with temperature and can be measured accurately, may form the basis of a thermometer for measuring temperature. With a liquid and glass thermometer, the volume of the liquid increases. At constant pressure, gas thermometers, the volume of the gas increases at constant pressure. At constant volume gas thermometers, the pressure of the gas increases at constant volume. With thermoelectric thermometers, such as thermocouples, electromotive force EMF produced varies non-linearly. Resistance thermometers use resistance increases, and with thermistors, the resistance usually decreases but increases for some types. Now here is a picture of 1, 2, 3, 4, 5, 6, 7 calibrated thermometers, and it's trying to test your skill on whether you could measure or read the calibrations. So we have 22 degrees Celsius, negative 5 degrees Celsius, 40 degrees Celsius, negative 15 degrees Celsius, 35 degrees Celsius, 5 degrees Celsius, and 18 degrees Celsius. What you can do is pause the video and just look at where you think it's going to be. Something like, or you could probably take a snap of it and try to do it on your own. And the next one will show you the answers, the next screen. Right. So when it comes to calibrating or reading a calibration or a scale, just know that if you're going from 0, you always increase, you always be going upwards, right? In the positive section. And if you're reading from 0 going down into the negative section, you'll be going downwards. So from 0, this would be 5 right here, then 10, so you're increasing. But in the 0 section, well, in the negative section, going from 0, this would be negative 5, and then you have negative 10, as you can see here. So you don't want to make any mistakes. So here we have negative 5, 40 up there, 15 down here, 35 up here, 5, and then 18. So this is 15 right here, plus 3 more, 1, 2, 3 will give you 18, right? Now, liquid and glass thermometers are based on the principle that the liquid will expand as its temperature increases and that this expansion is proportional to the increase in temperature. So once you expose it to some type of heat, the liquid inside of it should expand. A reservoir of liquid, such as mercury or colored alcohol, is contained at the bottom of the thermometer in a bulb, which you see right here. The reservoir is connected to a narrow capillary tube through which the liquid will expand and rise upwards. With good thermometers, droplets must not stick to the inside of the tube, or the reading will be low when the temperature is falling. Mercury freezes at negative 39 degrees Celsius and boils at 357 degrees Celsius and is suitable for high temperatures. Alcohol freezes at negative 115 degrees Celsius and boils at 78 degrees Celsius and is therefore more suitable for low temperatures. The thermometer can be calibrated by placing the bulb of the liquid in melting ice and then marking the level of the liquid in the capillary tube. This point would represent 0 degrees Celsius, since pure ice melts at this temperature. The bulb would then be placed in a liquid of pure boiling water, and the level the liquid expands to would represent the 100 degrees Celsius mark. And here is how it would be done in a picture format. Now the mark made at 0 degrees Celsius will be referred to as the lower limit, while the 100 degrees Celsius mark will be referred to as the upper limit. The distance between the 2 points would then be divided into 100 equal parts or divisions. And that's how you calibrate a thermometer. Now, an example of a liquid in glass thermometer is the clinical thermometers. The human body temperature is approximately 37 degrees Celsius and varies between 35 and 42 degrees Celsius. Because of this, clinical thermometers are designed to cover just that range. Because if we go below or beyond 45, 42 and 35, guess what? We are dying. Now, hence, clinical thermometers are very precise with temperature divisions of 0.1 degrees Celsius. The shape of the thermometer is designed to magnify the capillary tube so that it is easier to read the temperature. Clinical thermometers need to be removed from the patient before they can be read. To prevent an inaccurate reading as the liquid contracts, a small constriction is built into the thermometer that breaks the liquid thread, which is right here. The liquid can be returned to the bulb after reading by flicking the thermometer. That's where you see nurses and doctors and all those medical staff, when they take your temperature, they flick it if they're using these old type thermometers. Now, clinical thermometers take a few minutes to read because it takes a while for them to reach thermal equilibrium, and it takes a while for them to get an accurate temperature because they have to wait for it to equilibrate. So what's happening now is that they're becoming obsolete, and they're now using electric thermometers, which it's read much quicker, much quicker, yes. Now, the advantages of mercury thermometers. Mercury has high conductivity and low specific heat capacity. Therefore, temperature quickly adjusts to the temperature it is measuring. Mercury has a high boiling point of 357 degrees Celsius. If alcohol thermometers were used in the lab, it would evaporate and distill in the upper part of the bore. Mercury is bright silver and can be easily seen, and the thermometer has a linear scale, which is easy to read. Linear meaning a straight scale. Okay? Now, let's get back to the evaporating and distilling in the upper part of the bore. That would be more for those really upscale laboratories, like university-wise and stuff, because the laboratories we have here in the Caribbean, for the most part, we don't go beyond, at least, I don't think we go beyond 200 degrees Celsius. I don't think we go that far. Now that we go that low in temperature, I think the lowest we ever go is maybe -4, but that might just be my lab, but I don't know what happens in yours, I'm just saying. For the most part, I don't think we go that far, all the way up to 400 degrees Celsius, unless you're actually sticking your thermometer inside of the flame that's given off on the Bunsen burner. And that flame goes up to about 600 degrees Celsius. It cannot be used, so now the disadvantage of mercury, it cannot be used to measure very cold temperatures because mercury freezes at -39 degrees Celsius. It's expensive and mercury is poisonous. So if you happen to break a mercury thermometer, you need to report it. Okay? You need to report it. Do not keep it a secret. You keep it a secret, everybody's going to suffer in the end because mercury is actually a carcinogen. It can cause cancer. The vapors can cause cancer. Now here we have the thermocouple, another type of thermometer. A thermocouple consists of two wires of different materials. For example, copper and iron joined together. And we can see it right here. You have the copper wires, and then you have the iron joined up here, right? You have a hot junction and a cold junction. It is an electrical thermometer which relies on the potential difference between or produced when two different metals are connected. So the potential difference produced varies with temperature. Thermocouples can measure very high temperatures and then respond very quickly to temperature change. The potential difference they produce can also be recorded quite simply by data loggers or computers, so you don't have to do that work. It does the work for you. The potential difference is then converted and a temperature is shown on a digital display, making them very easy to read. Because of their efficiency, they are used quite a lot in industry. Now, these are the advantages of thermocouples. They respond quickly to temperature changes because the metals have very high conductivities, meaning they can conduct heat very well, and they have very low specific heat capacities, which means they could respond to heat changes very quickly. They could withstand very low and very high temperature changes, very high temperatures, and it can be connected to a digital display and computer systems, again making your work easier. Now the scale though is non-linear, but who cares if it's going to do all the work for you? And the measuring instrument used with a thermocouple must be sensitive to small changes in EMF, and this can be expensive, so they're expensive. Now with a gas thermometer, they use the fact that gases expand when they're exposed to heat, and so the temperature will increase. This expansion is proportional to the temperature change. If you look at it, here will be the low density gas, meaning that it's very light, and when you heat it up, it will affect this liquid column of mercury. And so it will press on the top level here at A, pushing it down. And if you want to know the height of the liquid column, well, you will just measure between C and D. So C must match up to A. So if A is down here, then that would be the new C, okay? And then the D would be always at the end of the other column. So from start to end, that is your height right there. Infrared thermometers measure the rate of emission of infrared radiation from objects. The intensity of this radiation depends on the temperature of the object. Hotter objects emit more radiation. Infrared thermometers can find the temperature of something without even touching that object. And you see that when you see the soldiers put on the little head cam in the forest and they go hunting, and they could see, out of that wall, and they could see moving bodies, the red portion. That's the human being that they want to shoot. Now, it is important not to confuse the temperature of a body with the heat or thermal energy that can be obtained from it. Heat is the energy provided to cause particles to vibrate, while temperature, on the other hand, is a measurement of the heat in kelvins, degrees Celsius, or degree Fahrenheit. So temperature is a measurement of heat, while heat is the energy that is provided to the atoms or particles to vibrate. Yeah. Now, temperature decides the direction in which heat flows, just as pressure does in liquid flow and voltage does in the flow of electrons. Now, thermal energy is transferred from a body at a higher temperature to one at a lower temperature. A liquid flows of its own accord from a higher pressure to a lower one. The kinetic theory regards temperature as a measure of the average kinetic energy of the atoms or molecules of the body. The greater the kinetic energy, the faster the molecules move and the higher the temperature. Which makes a lot of sense, because if we are all packed like sardine in a room, what's going to happen? We're going to get agitated and we're going to start to vibrate, and the temperature is going to go up, and so are the attitudes, the feelings, and the tempers. Right? So you can think of it like that. Now let's do some fill in the blanks. Read it, absorb, and let's answer now. Heat is transferred from a body at a higher temperature to one at a lower temperature, because the average kinetic energy and speed of the molecules in the hot body falls as a result of the collisions with the molecules of the cold body. After a while, you're going to get tired of boxing and vibrating. You're going to get tired. Now, when the average kinetic energy of molecules is the same in each body, they're at the same temperature. Namaste. Now, we are done with part 2. Ooh, la, 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 la. Now, on the Celsius temperature scale, what is the lower fixed point? Correct, 0 degrees Celsius. And the upper fixed point is 100 degrees Celsius. How would you calibrate an unmarked mercury thermometer? Correct. You would dip it in pure ice to get the lower limit, which is 0 degrees Celsius, and then you would raise it above boiling water to take the temperature of the vapors, pure boiling water at that, to get 100 degrees Celsius. Then you will calibrate like equally 100 divisions in between them. Which one of the following helps a liquid in glass thermometer to record a change of temperature rapidly? Is it a long stem, a large bulb, a narrow stem, a thick walled bulb, or a thin walled bulb? Right, when you're dealing with these things, dealing with sensitivity, they want it to be a thin walled bulb. State 3 advantages and 1 disadvantage of a mercury thermometer. Correct. So, advantage number 1, you can see the silver lining going up the thermometer. Advantage number 2, what is it? It has a low specific heat capacity and high conductivity. So that's 2, that's 3 right there, right? And then a disadvantage is that it's poisonous or it's very expensive. So poisonous and or very expensive. Now state 1 advantage and 1 disadvantage of an alcohol thermometer. 1 advantage, it's cheaper. And a disadvantage would be that the temperature range is not wide enough for the laboratory, which could lead to it vaporizing inside of the capillary tube. Now explain why a clinical thermometer covers a small temperature range. Because it's being used to test humans. And our temperature range is very small, so there's no need to make long thermometers for that. Now, has a constriction above the bulb to increase accuracy once the thermometer has been removed from the body, so that it doesn't fall back down into the bulb. So you want to get accurate measurements or accurate data. Has a very narrow tube. Well, that's so that the liquid doesn't fall back. That's my answer for that one. Now, why can a thermocouple thermometer measure rapidly changing temperatures? Because it has 2 different metals that are very sensitive to differences in potential difference, and that's what makes it quick. It makes it quick at picking up the change in temperature, right? So its design lends to its ability to rapidly to measure temperatures that change rapidly. That's what it is, it's design. So we're done with part 2, and now we're going to move on to part 3. So look out for that video. Bye!